All right, let's talk about the absolute building blocks of programming in Go. If you've ever wanted to build software that's fast and reliable, you are in the right place, because it all starts right here with the fundamentals. So let's start with a really basic question, one that gets to the very heart of how computers think. How does a program know that the number 25 is something you could do math with, but the name John is, well, just text? The answer is a super important concept called data types. The best way to think about them is like specialized containers. One container is shaped perfectly to hold a number, another one is designed just for text, and a third can only hold a simple yes or no. It's like a sorting system that stops you from putting the wrong stuff in the wrong box. Now, this is a really big deal in Go, because Go is what we call a strongly typed language. What that means is, it won't just let you mix and match these containers carelessly. It makes you declare what kind of data you're storing, which might feel a little strict at first, but trust me, it's a lifesaver. It prevents so many bugs by making your code way more predictable. Okay, let's dive in and get our hands dirty with the first and probably most common data type you'll ever use, integers. These are the absolute workhorses of the programming world. So, integers are your go-to for any kind of whole number. Positive, negative, zero, as long as there's no decimal point, you're good. You see them everywhere, counting items in a shopping cart, giving a user a unique ID, or just keeping track of how many times a loop has run. And check out how clean this is in Go. We just use this cool little I equals syntax. Go's compiler is smart enough to see the number 25, realize it's a whole number, and just, poof, it makes the age variable an integer automatically. It's so efficient. Okay, so whole numbers are covered. But what about all the other numbers? The ones that aren't so neat and tidy. For that, we need to talk about floats. Anytime you're dealing with a value that isn't a perfect whole number, think product prices, scientific measurements, temperatures, that's where floating point numbers, or floats, come in. In Go, the one you'll use most of the time is called float 64, and it gives you a ton of precision. And just like with integers, Go makes this super easy. The second the compiler sees that decimal point in 1999, it just knows. It knows this isn't an integer, and it automatically makes the price variable the right float type. No extra work needed. All right, let's switch gears to something completely different but oh so powerful. This next type is the foundation of all decision-making in your code. I'm talking about the boolean. Booleans are just beautifully simple. A variable of this type can only ever be one of two things, true or false. That's it. This simple binary choice is the engine of all logic in your programs. Is the user logged in? Is this feature turned on? True or false? That's all you need. So here, we just set a variable to true. And now? Well, now we can use that isLoggedIn variable to control everything. We can put it in an if statement and completely change what our program does. If it's true, maybe we show the user's dashboard. If it's false, we send them back to the login page. It's that powerful. All right, we've handled numbers and logic. So what about words? How do our programs deal with the messy human world of text? Well, for that, we have strings. Anything you can type basically is a string, from a single letter to an entire novel. Usernames, email addresses, error messages. If it's text, it's a string. And in Go, you make one just by wrapping your text in double quotes. Seriously, that's good. You just wrap Alice in double quotes, and you're done. Go now knows that the name variable is a string, and you can print it, save it, whatever you need to do. Okay, now for my favorite part. This is where it all clicks. See, on their own, these types are like individual Lego bricks. They're useful, sure, but their real power, that's unlocked when you start snapping them together. Let's see how we can represent something real. I mean, just look at what we've done here. We've combined a string for a name, an integer for an age, a float for a price, and a boolean to check membership, and all of a sudden, we're not just dealing with abstract pieces of data anymore. We've actually built a simple digital model of a real user. That right there, that's the whole game. That's programming. And this is why this all matters so much. This isn't just about getting it right. The choices you make here, using an integer instead of a float, for example, directly impacts your program's performance. It changes how much memory it uses, how fast it runs, and how reliable it is in the long run. Getting this right is a truly fundamental skill. So integers, floats, booleans, and strings, these four things, they are literally the atoms that every single application is built from the simplest script to a massive global service. Once you master these, you can build anything you can imagine. So I guess the only question left is, what will you build? Hey, if this breakdown helped things click for you, do me a favor and subscribe. We've got a lot more explainers coming to help you turn these simple building blocks into some seriously powerful software. Thanks for watching.